Greetings guys, this magnanimous lectures online. We continue to treat the test 2 question paper of engineering science N3 that was written on the 28th of October 2019. This is question 4 which is about hydraulics. The question has the following information. It says the diameter of the ram is 55 millimeters, force applied to plunger 300 newtons, diameter of the plunger 12 millimeters, plunger stroke it's 200 millimeters. And then they say if the mechanical efficiency of the hydraulic system is 80% and that of the lever system is 85%, calculate the following. So firstly, we would like to explain the percentages or the efficiencies that were given here. The mechanical efficiency of the hydraulic system, it's 80%. This is what's happening inside the hydraulic system. So this is the internal operation, the efficiency of the internal operation. So we use this 80% when calculating anything that has to do with the internal operation. And then the 85% of the lever system is for the external operation. And we use this value when calculating anything that has to do with the external operation of the system. So let's attempt to answer the questions. So 4.1 says calculate the volume of the liquid displaced after 5 pumping strokes of the plunger. So we know that the volume displaced by the plunger for each stroke, like per stroke, it's going to be pi d squared over 4 times the stroke length, which we can say it's h in this case. So since we are told that it's being pumped for 5 strokes, then we multiply by the number of strokes. Since this it's per stroke, so you can tell per stroke multiply by 5 strokes. So this is the volume displaced. But we are told that like the hydraulic system, the internal operation operates at is 80% efficiency. So that means not all of this volume will be displaced, only 80% of it. So we multiply by the efficiency, which is represented by this symbol. And if we plug in what we are given, it's going to be pi. Oh, and here it's a small d, this is the diameter of the plunger. It's going to be pi times the diameter of the plunger, which is 12 millimeters times 10 to the power negative 3, all squared over 4 times the stroke length, which is 200 millimeters. It's going to be 200 times 10 to the power negative 3 times the number of strokes, which is 5, times the efficiency of the internal operation, which is 8. And if we punch this into the calculator, it's going to give us pi times 12 times 10 to the power negative 3 all squared over 4 times 200 times 10 to the power 3 times 5 times 80%. This gives us 9.0477 times 10 to the power negative 5 meters cubed. And if we write this down in decimal form, it's going to be 0.00090,477 meter cubed. and if we round off, it's going to be 0.000091 meters cubed. That's it for question 4.1. Question 4.2, it says the distance in millimeters that the ram piston will move after 5 strokes. Then we go to our formula sheet and check the formula that we can use, and if we do that, we find that we can use the formula which says diameter of plunger squared times the stroke length times the number of strokes equals to diameter of ram times the displacement of the ram. Let's say it's h. And then since we are told that like this system is not operating at 100% efficiency, that means we should multiply this side of the plunger with the efficiency, which is represented by this symbol. And then since we are looking for the distance that the ram will be displayed after 5 strokes, we can make h subject of the formula, and it's going to be, therefore h equals to efficiency diameter of plunger times stroke length times number of strokes over diameter of ram squared. We substitute what we're given, so it's going to be 80% times 12 times 10 to the power 3, since it's 12 millimeters squared, times stroke length 200 times 10 to the power negative 3 times the number of strokes, which is 5, all over diameter of ram, and we are told that the diameter of the ram is 55 millimeters. 55 times 10 to the power negative 3 all squared. Then this gives us, let's punch this into the calculator, 80% times 12 times 10 to the power negative 3 close bracket squared times 200 times 10 to the power negative 3 times 5 all over 5 times 10 to the power negative 3 squared. And that's what we get, but I think there's a mistake somewhere. Let me check if I punched everything properly. I made a mistake here. I wrote 5 and it should be 55. So I think it should be fine by now. Let me close this bracket here. There we go. It gives us 0.038083 meters, and if we convert this to millimeters, which is multiplying by 1000, it's going to be 38.083 millimeters. That's 4.2. Question 4.3 says the force exerted by the ram piston in kilonewtons. So this part also has to do with the internal operation, because it has to do with the force that's been transferred due to the pressure inside the hydraulic system. That means it's from the plunger to the ram. So we'll use the formula 4.3. F equals to D squared equal, no, F over D squared equals to bigger F over bigger D squared. And then we know that this is the diameter of the plunger and this is the diameter of the ram. This is the force of the plunger, this is the force of the what you call ram, and we can represent this as weight. So this is how it is. And then to make to get like the force exerted by the ram piston, we make the subject of the formula and take it as a weight. So we're going to say W weight is equals to diameter of ram times the force applied by the plunger over the diameter of the plunger equals to, and we substitute what we are given. What we are given is that the diameter of the plunger is of the ram is 55 millimeters all squared times the force. Here they say the force applied to the plunger, it's 300 newtons, so it's 300 all over the diameter of the plunger, which is 12 millimeters all squared. We punch this into the calculator, see what we get. 55 times 10 to the power negative 3 squared times 300 over 12 times 10 to the power negative 3 squared. It's going to give us 6,302.083 newtons. We represent this force exerted by the ram as W, which is the weight, because like usually the ram has something it is lifting, and that something has weight which it's acting downwards, which is exerted on top of the ram. That's why we represent it as weight. And then since we are told that the system is operating at 80% efficiency, that means not all of this will be exerted, only 80% of it, and we therefore multiply this by 80% to get the exact amount of force that's being exerted. So say that times 80%, and it's going to give us 5,041.66. We are told to represent it in kilonewtons, so we divide by 1,000 and we get that. So it's going to be 5.0417 kilonewtons. That's question 4.3. And then question 4.4 says calculate the force exerted by the ram piston in kg. So that's just converting this to kgs. So we're going to say force equals to mass times acceleration, and then our mass equals to force over acceleration. We've got our force here and our acceleration, since these things are just like the weight is acting vertically downwards, and it's only gravitational acceleration that's acting on it. So we're going to use our acceleration as 9.8. So we're going to say 5.0417 times 10 to the power 3, since it's kilo, divided by 9.8. Divided by 9.8. Punch that into the calculator. We get 514.0 4.459 kg. That's it for 4.4. Then 4.5 says the effort that must be applied to the lever in order to obtain a force of 300 newtons on the plunger if the mechanical advantage of the system is 10. So we go back to our formula sheet to look for the similar for mechanical advantage. And the formula isn't there in the formula sheet, but it says mechanical advantage equals to load over effort. And then in our question here, we are told that we should find the effort find the effort that must be applied to the lever in order to obtain a force of 300 newtons on the plunger if the mechanical advantage of the system is 10. So our effort E is going to be our load over the mechanical advantage, which is going to be 300 over 10. It gives us 30 newton. But then we are told that the external operation of the system operates at 80% efficiency. So our actual effort is going to be this 30 over 85%, and we get punch this into the calculator. 30 over percent, we get 35.29 35.294 newtons. You'll ask yourself why we are dividing by 85. We are dividing by 85 because efficiency equals to E out over E in, and here we are looking for E in. So this is our E in and this is our E out. So if we make E in subject of the formula, it's going to be E in equals to E out over this, and this E out is 30. That's the one that's given into the hydraulic system, and the efficiency 85%. And this is what we apply to the lever, and then some of it's lost there in the external system of the hydraulic system. So that's how this came about. And then question 4.6 says the effort that must be applied to the lever in order to obtain a force of 300 newtons on the plunger if the mechanical advantage of the system is 10. Answer must be in kilograms. So this is just converting the effort that we got in newtons to kilograms, and we're going to say mass equals to F over acceleration, which is 35.294 over 9.8. Punch this into the calculator, it's going to be 35.294 over 9.8. Going to get 3.6014 kg. 4.7 says the actual mechanical advantage of the system. So we know efficiency equals to mechanical advantage output over mechanical advantage input. So Our actual mechanical advantage of the system, it's mechanical advantage output equals to efficiency times mechanical advantage input. So that's 85%, since the mechanical advantage has to do with the external operation of the hydraulic system, times the given mechanical advantage, which is 10, and we end up with 8.5. That's it for question 4.